Now let's talk about the materials. Again, you can see from the two different colors. Well, I know this one is painted. If you can take a look to the faces here, you can have one of the faces is going to be the shiny one. And that's telling me that this pump is made of aluminium, and this one is the gray cast iron. If you're not convinced with the color, because you can say, oh, well, it's made of steel, another proof for that is, after taking the shaft out, I can tell by the weight. This one's light, this one's heavy. Now why? Because the density is different. I know that the size of this one is small, but the density is going to be the main thing. Now, why we selected two different types of metal here? Now, one of the reasons are, first, we're making the pumps. We're going to pump different liquids using these pumps. Some of the metals is going to be more sensitive to be attacked by certain types of the liquids. If I'm going to have acidic, for example, I cannot use certain types of the steel or the cast iron, and vice versa for the aluminium. So this one of the examples. Also, we're talking about the condition of the operations and the application we're going to have for these pumps. The metal pump usually is going to take higher pressure because the body is going to be stronger. It's going to have higher strength, and thus is going to have higher internal pressure inside. While for the aluminium, it's going to be less strength than the metal, than the steel or the gray cast iron, and it can take less pressure, of course. Now, when I talk about the pressure, that's mean even the flow rate is going to be less. So the application is going to be another reason for choosing different metals for the pumps. The other point is, okay, now the ease of manufacturing. If you are going to make a pump, for example, you work in a company and you have one of these pumps, and what happened is that due to the vibration or so for certain thing happened to your machine, we had a crack on the case here. And this crack actually cannot, for example, cannot be welded and fixed. So in that case, you may need to make the body. You check the application you have. It's going to be just a normal hydraulic, no sulfuric thing that may damage the metal. Then you can choose the metal you have in your factory. You may have a small foundry in your place, or maybe you have the ability to melt the metal, but it's not going to be high enough to melt cast iron. It's not going to be high enough to melt the steel, which is going to, of course, have higher temperature. Melting plus of course, you know that we have to add the heat of fusion, then the heat of pouring to make it very soluble to do the work. So the aluminium, of course, is going to be a good option to do that. Okay, so the aluminium also going to be, the metal is going to be also used based on the manufacturability you have in your factory. After when we talk about the machining process, of course, the steel or the gray cast iron or whatever the super alloys is going to require more energy to be machined rather than the aluminium. So now we have different points that we are going to look at every time when we are going to select the metal for our products. That's part of the material selection. I'm not going to consider that as the design for manufacturing. I'm going to go for design for manufacturing later. Okay, so now we talked about the metal, and we're going to go for the other parts and what the metal they have in. First, we have, for example, the sets of the seals. Once again, the selection of the seals should be selected according to the fluid you are going to use to pump. So for example, if I'm going to have a certain types of the latex, is going to be sensitive to certain type of the liquids that's may damage it in a few hours. It's going to be very soluble and got damaged very fast. So the selection of other compounds also going to be depend on the fluid we are going to work on. Now we're talking about the shaft. The shaft is going to rotate at very high speed. If we're going to have bad design for the shaft will be twisted and both broken. So we have to worry that the shaft actually must be made of steel. Now you say, okay, now what about the different chemicals that may damage it? We can have actually a coating. We learned about the surface treatment. Against, it's not only the heat surface treatment, we can simply coat it with a metal that with the certain amount of layer thickness that may protect it from the liquid we are pumping in this pump. Why it's always made of steel, and it's always going to start from the steel bar that's going to be machined to a certain diameters, and then go the gear cut it and the supply cut it, because we cannot make the gear made by 3D printing, forget that. And also you cannot do it, of course, by the casting operation, because the property is going to be weaker in that case. The other components we have inside the pump, you will see that we have, well, actually it's much easier to show you that in the cup here. We can have a cylindrical part inside, we call it the pushes. Okay, these pushes will working as a bearing. It's going to protect the shaft from damaging the main body by hosting the shaft within. Okay, so it's something like the bearing operation. We are going to have a liquid running through the pump, so the liquid is going to have a layer between the shaft wall and the pushes wall, and it's going to be something like floating. Actually the shaft will be floating inside the pushes. One of the most important points we have to think about, that these pushes, which made of steel, should be covered with a layer of Teflon. We're spraying the Teflon on it during the manufacturing process, and this Teflon actually is going to retain some of the liquid within this Teflon layer that prevent the process of the dry running next time we're going to run the pump. If I'm going to stop using the pump for days or weeks, then I will come next time to run it. I have to expect that the pump maybe is going to be dry from the oil. All the oil actually has been emptied, or maybe the level is going to be to here and the upper one is going to be empty. So in that case we may have the risk that the contact between the shaft and the push is going to be dry. So when I'm going to start the operating of the pump, this may have a very high friction that may damage the shaft. So the Teflon will retain some of the oil, and this will avoid the dry starting for the pump. What else do we have? We have something called the thruster plate. The thruster plate will be sitting between the shaft and the top of the top part. Actually, I'm going to show you where it's going to be the position of the thruster plate. So I assemble the pump. Now here you can see that we have a gap between this level, that level, and the gear level. You can see my finger is going to go a certain gap. So we have something like that called thruster plate. The thruster plate must be made of a metal that is going to be weaker than the shaft itself, and it's going to be sitting between the shaft's gear side and the cap of the pump. So when we're going to have the high speed running of the pump, the shaft actually is going to eroding this part instead of eroding the cap. And this actually we can have another one down there as well. And this will save this part, because if I would like to overhaul the pump, changing most of the components, I need to avoid overhauling the body or the shaft, because you will see that the process of manufacturing these two parts is going to be quite complicated and costly. So just change the thruster plate, which is going to be sitting here, okay, and the cup will sit at the top, okay, and done. So I only need to open it, take the thruster plate, change this one, and change some of the seals, and the pump running for a new life. The last thing we have for the pump, thrust plate for this pump is going to be aluminium, done by the die casting operation. We're going to talk about manufacturing process later. While this one is made of a different type of steel, which is going to be done by the stamping operation. It's cut off one part, one plate, okay, done by the stamping, and we got the part ready. The last thing we're going to talk about is something called the dowel. If you can see this pin here, actually this pin is just a cylindrical pump with a very high tolerances and have very good surface finishing. It's done by cutting a row to small pellets, and then these pellets are going to be, of course, sitting in the dowel holes, and it's going to be used for the alignments of the two parts. So when the dowel is going to be sitting on the other half of the body, it's going to tell me exactly what will be the location I should put the head on, and how the bolts actually is going to be fixed in position, that no shafting that causing any load, side load, or what we call the radial load on the shafts, and thus the pump will perfectly working without any extra forces to be exerted on the shafts. Now the next section is going to be about manufacturing process of every part, and the third one is going to be about the dimensioning.